My name is Terry. The paper I've chosen today is Diversify and Conquer Diversity-Centric Data Selection with Iterative Refinement. So how can we improve on this paper? So first of all, I think it's necessary to come up with a rigorous definition of what diversity is and rigorously define what higher quality is. Um, like is higher quality, how much the data influences the final outputs, accuracy, or is it the perplexity of the data points? This will really impact like our methodology. So I think it's important to really clarify. And also, representation and distance also impact our methodology. So is like, cosine similarity of LM output embeddings really enough? Is to capture diversity? Is perplexity enough to capture quality? I think these are questions we really need to think about. And also, why are we simply only using linear clustering methods? Like, can we try to use nonlinear clustering methods like spectral clustering, dbScan, kernel k-means, mean shift clustering? Since these nonlinear methods may capture higher level abstractions that linear methods just fail to capture. And our results of more diversity might not hold in those regimes. Also, I think it's important to ask the question, like, why does diversity really improve instruction tuning results? Is it because of, better coverage of the task-based distribution? Um, this is usually the explanation from the core set literature. And more specific to this paper is like, why does iterative refinement work? Like, when I read the paper, it kind of reminded me of like the boosting idea, like where we reweight different data points. Except, now we don't really ensemble like different weak learners at the end. Um, and also like it kind of reminded me of like domain reweighting or like data reweighting. But just how can we come up with the theory and answer the question of why? So next, what we can improve on is also, practical improvements. So does diversity always help in all regimes? The current paper only tests like 7 and 8 billion parameter models, but what about for even bigger models? Like maybe this diversity phenomena doesn't hold for maybe large models. And furthermore, like, can we cast this problem as um, an optimization problem rather than, simply just choosing a k-means clustering algorithm based off heuristics? Can we come up with a more automated way? And also, what is the right trade-off between diversity and quality? From the QDIT paper that was cited in the current paper, they just treat, diversity and quality trade-off as a hyperparameter. But this might not always be optimal. So, can we come up with a theory like, or like a statistical model to like be able to decide between these two? And furthermore, like, why does diversity or how does diversity benefit the different stages of language model training? So is instruction tuning like gonna get as much improvement from diversity as like pre-training, or maybe preference optimization actually benefits the most? And there's actually some evidence of this from the generalization and diversity paper from Facebook last year. And just some adjacent ideas that I had were trying to use smaller models to do data selection for larger models. This was actually a project I was working on before, and the idea is that like if I have a 1 billion parameter llama, can I use like gradient-based data selection methods um, to find good data points that I can use to fine-tune a larger model? Because for gradient-based methods, the real computational bottleneck is computing the Hessian um, of the landscape, and that's dependent on the dimensionality. So it would be really infeasible to do this for a gigantic model. So if we can, you know, find some type of correlation between the smaller and larger model, their Hessians, then we can use the smaller model. And one of the key like insights that I was trying to come up with is that like for models of the same family, such as like, same llama family, maybe their Hessians are like related in some way. Another question I wanted to ask is, can we come up with some type of like information theoretic or mathematical linguistic explanation of why um, or what attributes improve linguistic knowledge transfer uh, in the data? Like, does data with similar syntax help or more mutual information? These are just some other ideas that I had. But yeah, thank you for listening.